Hey guys, so this section is going to be talking all about logistic and exponential graphs, and those are really important because that's how we end up tracking populations of organisms. So, on the first question that we have, which graph is exponential growth and which one is logistic growth? So, what we should remember from this is that exponential growth is growth that is exploding. The population is exploding. There's no end in sight. While logistic growth is a more realistic thing that we see in nature, where yes, there is an explosion in the population, but eventually it evens out. And with that, you should be able to say that the exponential growth is actually the one on the left, while the logistic growth is the one on the right. Exponential growth explodes in the beginning, just like how the one on the left is, while logistic growth did have that explosion right here, but eventually it reaches its carrying capacity, which is where it evens out and becomes a stable point to hold the population. Now let's go to the next one. What does the carrying capacity represent, and in which graph would you see it, and at what point? So the carrying capacity represents the amount of that organism species that can exist. So every species has a carrying capacity in its environment. For some of them, it could be 40 of them, 100 of them, 1,000 of them, maybe a million of them. But every species has a carrying capacity, and that's how many of that organism can be maintained in the ecosystem. Now, at which graph would you see it and at what point? Well, we would see that in the logistic graph. And we would see it right around here when we start doing the evening out. And so we start seeing the carrying capacity whenever we start approaching it. So different things can lead to us reaching that carrying capacity. For example, we no longer have unlimited resources, or we've made it to a point where now we're starting to get more predators or competition has increased. These are all things that can make us see the carrying capacity, but you'll see it right here at the very tippy top of our graph on this area, because that's where the line is. That's where we even out. When you're evening out, that's when you see your carrying capacity. Now, a population of organisms experiences exponential growth to their population in the beginning. This eventually stops when the population reaches the carrying capacity. Name two actions that the organisms in the population could undergo that could lead to the population experiencing logistic growth instead of exponential. Think about what happens to the individuals when there's no longer unlimited resources. So this is the problem where I do expect some of you guys to be confused about it, or maybe not even get it, but that's okay because you're going to listen to what I'm saying and you're going to process it and you're going to get it. So let's look back to the graph. So in the exponential, we had unlimited resources, everything was fine. When the logistic, we start reaching up and we no longer have unlimited resources. So the population is going to even out. That means it's no longer going to grow. So a couple things could happen. If we no longer have unlimited resources, more of our organisms are starting to die. And another thing that could happen is when we no longer have unlimited resources, we start having less babies. So more organisms are dying and less babies are being born because the resources are now limited. They were unlimited, but now they're limited. On top of that, another thing that could happen, we no longer have organisms moving into the area. So one of the things that can increase the size of a population is more of the species moves in. But we could, once we start having a limit on our resources, organisms don't want to move in. And as a matter of fact, some of them are going to move out. And so we actually have a word for that: immigration and emigration. Immigration and emigration of organisms. So let's break it down real quick for you guys in case you may be still a little bit confused. Let's take a city, for example. Let's take Houston, for example. Now, let's go back, way back in the day. So Houston was a city full of resources, unlimited resources basically, because there was nobody to use them. So what happened? Well, in the beginning, there was a lot of people. A lot of people were there, and more people were coming in. More and more people were doing immigration. They were immigrating into the city. So the human population skyrocketed because we were having a lot of babies and we are having a lot of people move in. But then eventually we hit a point where it's like, okay, we're actually starting to run out of resources. We no longer have unlimited resources. So when you hit that point, more humans are dying because we no longer have unlimited resources. People stop having babies because it's not a healthy thing to have a big family if you don't have enough to feed them. Immigration stopped because nobody wants to move into a place that doesn't have resources. And emigration stopped. Emigration, where people started leaving the city. Emigration, remember, emigration is with an E. Think about exit, E for exit. That's a real human example, but all organisms do that whenever they're reaching their carrying capacity. They will stop having babies, the birth rate declines, the amount of organisms that die increase, immigration stops because people are not moving in there or organisms are not moving in there, and emigration increases. Organisms will leave to find more resources somewhere else. So those are those examples for that problem. Now, go to this next one. Invasive species experience exponential growth when they first arrive in an ecosystem. What advantages do they have that allow them to grow exponentially? So they definitely do have some advantages. So whenever they show up, number one, they don't have any predators. There's no organisms there that know they can eat them. So they're actually not going to eat them. Number two, they could just be better at competing for food. Some organisms are super aggressive and they might outcompete the ones that are there. Number three, some of them are really good at reproducing. And even if they're not as good at competing, there'll be so many of them that they take over. And number four, some of them are just better made for an ecosystem. Sometimes you introduce an organism and it's just like, oh, it can live there better. It's just better adapted for that environment than the ones that are actually there, which is crazy, but it does happen. Now, can populations of organisms not grow exponentially forever? Well, the answer is simple. You run out of resources. Eventually, you're going to run out of resources, and that's when growth stops. And resources can be anything. It can be water, it could be food. You could run out of mates, or you can even run out of space. But eventually, all species are going to go from exponential into logistic growth. That's the natural thing. It'll always start off like this, in exponential, and eventually they're going to go into logistic because we're going to reach a carrying capacity. Us humans are actually in the exponential phase right now. Eventually, we are going to go ahead and reach our logistic growth. We're going to reach our carrying capacity, and we're just going to even out, and we're going to have a flat number of humans on the planet, which I think is about 11 billion right now. But yes, guys, that's the logistic and exponential growth portion. The main idea that I want you guys to take away from this is what these graphs look like, what the carrying capacity represents, and the fact that all organisms go through this. Even our invasive species, they will grow exponentially, but eventually they'll even out into a logistic growth. Eventually they'll become a part of that ecosystem and they'll even out. They'll have a carrying capacity too. But all right, guys, I'm going to cut the video there. You guys, I'll see you in the next section. Bye.